Welcome everyone to the NeurIPS LXAI Workshop 2021. It is an honor today to be delivering this keynote on Meditations on First Deployment, a practical guide to responsible AI. A little bit about myself. My name is Alejandro Saucedo. I'm Engineering Director at Ceylon Technologies, Chief Scientist at the Institute for Ethical AI, and Governing Council Member at Large at the ACM. So today we're going to be covering a broad range of very interesting topics. We're going to be delving into the motivations for responsible AI. We're going to be covering some concepts such as the responsibility hierarchies, some ways in which you as practitioners can contribute and get involved through what we call the different areas of programmatic governance. We're going to delve into some production considerations on the more practical aspect, and then we'll bring all of this together through a practical example. So a lot to cover, and each of the slides pretty much that we cover in this session have respective 1 hour plus content that we link and would encourage people to delve into if you are interested in. So let's get started. The motivation for this is to acknowledge that critical infrastructure is increasingly dependent on the machine learning systems that we develop, that we design, that we research, that we publish. And regardless on how many layers of software or hardware abstractions we create, the impact of these systems will always be human at the individual and societal level, right? And from that perspective, we will acknowledge that as practitioners, we do have a growing professional responsibility to our craft, right? This is primarily given that the research that we publish, the algorithms that we deploy, the systems that we design, develop, and operate have an impact that can go well beyond just the single users. And this could go to a societal level in different areas that we have seen a lot of cases in high-profile cases. Ultimately, there is a very interesting resource that covers a lot of interesting, cases of awful AI, as they refer to it. But as a premise, we just acknowledge that the impact and understand that the impact of a bad solution can be worse than no solution at all, right? And this is going to be a sort of core theme, that it is a question of not just whether we're going to be using AI to solve a particular problem, but it's also the question of how much and how we're going to be using all of these tools at our disposal. Now, ultimately, it is important that as practitioners, we have to acknowledge that we do have that professional responsibility and some key things that we can do to ensure that what we're doing is at its best or optimal sort of sense. As an individual practitioner, you can make sure that you have the right technologies, tools at your disposal, that you have the right competence in the field that you're developing or researching, and that you have, as we're going to be delving into, the different tooling that you can leverage for your individual contributions. But one thing that perhaps we have seen in many cases is that an ethical or responsible individual does not equate to a responsible compound, right? And this compound can be all the way to a team, to a department, to an organization, to an industry, right? And because of that, it is important to understand what is the interplay and responsibilities that are involved when it comes to those higher pieces. In the case of the teams, ensuring that there is the right cross-functional skill sets, that there are the relevant domain experts that are being brought in when necessary, that there is an alignment on that principled level, that there is an accountability structure that is defined on the relevant responsibilities, as well as on a higher perspective, the organizational department or even larger perspective, that there are those higher level principles or Northern Stars, that there is the governing structure in place, the right communication processes are set in place throughout this different phases of the machine learning lifecycle, whether it is from the research, the design, the development, operation, etc., etc. Now, once we've actually gotten a bit of an intuition of the different levels of this responsibility hierarchy, we understand how complex it is that is not just about oneself doing what would be in a way the responsible perspective. And the reason why I'm mentioning this is that contrary to perhaps some superficial ways of seeing those very challenging problems, it is something that we need to get into consensus that large ethical challenges like this cannot fall on the shoulders of a single data scientist or a single software engineer or a single researcher. And the reason why is because the skill set that is necessary to be able to tackle these different challenges require the best practices of not just this technical machine learning expertise, which already breaks down into different areas of state-of-the-art or advanced, complex, specialized research with what could be the software engineering best practices, together with the even DevOps and operational considerations for the systems themselves. But then the intersections that come with the domain-specific use case, the domain experts, as well as those higher level standards or policies that would then intersect to define what could be those higher level principles or industry standards or regulatory frameworks. So ultimately, what we want to set kind of like as a core motivation is that this is a challenging issue that cannot just be solved by one single individual, that has to be resolved by a cross-functional set of diverse individuals in continuous interplay throughout the operational engagement of the development of the different phases of these machine learning systems. Now, what this would look like in a bit more, still abstract, but more practical perspective is through what we are going to refer as the programmatic governance components. And the reason why we call it governance and programmatic is because it emphasizes the end-to-end interaction between what could be this very high level, very abstract ethics guidelines or principles that can define that sort of northern star to go towards, then going deeper into the more practical industry standards or regulatory frameworks that define what are the core rules, regulations that need to be in place, or the best practices and what those best practices actually are, and then going deeper with those software libraries, the actual tooling that the practitioners are using and building on the more practical aspect. And the reason why this is important is because if we don't have those higher level principles taken into consideration and built by design from those underlying software components or the underlying infrastructure, it doesn't matter how many round tables we have to agree that algorithmic bias is bad or to agree that doing harm to humans is bad. We're not going to be able to ensure that this is introduced, that this is set from a practical perspective, let alone ensure that this can have longevity in an operational perspective once it's in production, once it's being used. So it's important to ensure that sort of end-to-end approach to what we're going to be referring to as programmatic governance. Now, from each of these areas, we're going to delve into how, as practitioners, we can not only understand what they refer to, but also, and more importantly, how we can ensure that we can contribute to them, right? And actually help towards the direction and definition of each of them. Starting with the higher level principles, what we have been able to see, and most likely everyone in the audience, is that a lot of organizations have been publishing their own AI ethics principles, right? This is a broad range of different tech companies publishing their own. Now, this may raise the question of are all of these different principles that have been published completely different? Well, ultimately, they have all been, fortunately, very similar to a certain extent, to the extent that there has been some interesting surveys and research that has analyzed and compiled all of these different principles that have been published and identified what has been some of the core similarities and trends across them. And for most of them, they actually refer to what is a standardized set of 7 or 10 different principles. Now, from that piece, before we delve into why these principles may be useful or how we can contribute or leverage some of this as practitioners and how they're relevant to us, we need to understand why they're even important. Because there is a lot of terminology that at this point in certain situations may even be used as buzzwords. The words of ethics and principles. Why should we actually care about this different terminology being thrown around? But when you as practitioners see the actual definitions, ethics being these moral principles that govern, an individual's or practitioner's behavior or activities when we carry out our craft, or principles, the fundamental truths or northern stars that we can all align into to gain that deeper level of empathy and alignment and agreement. These are important because it does allow us to understand what is the direction when we actually find ourselves in an unknown situation. Because we may ask the question of, well, as practitioners, why wouldn't we just use the existing rules that are in place for us just to leverage? And the challenge is that when dealing with emerging technology that has never not only been deployed, but also never been in such a massive scale with the impact that it may have with society, we need to be able to identify and abstract from those existing foundational areas of knowledge how we can act in the most optimal or responsible way in what we're doing, by identifying what should be the right domain experts that we have to pull in, what are the things that we have to take into consideration, what is the actual priority of the value of that we have to actually pay attention to, and more importantly, also be able to leverage this foundational, core thinking frameworks or knowledge frameworks to be able to understand when an existing rule may perhaps not be applicable to the type of work that we are doing, right? And this is equally important to be able to understand that perhaps for the technology that we're developing or designing or deploying, the rules that have been built as may not be the most optimal for what we're using. Now, from that, terminology, there could be even a higher level question of, well, you're talking about ethics. There's a question of like, well, whose ethics? And, is it going to be Eastern ethics, Western ethics? However, we actually did some really interesting work, in one of the events that we actually run that we link here, is that ultimately, because of that, consistency of this of the different published principles that have been done across all of these different tech companies across the world being already aligned, that is not about just choosing a school of thought and saying I'm going to build software development with this ethical guidelines, ethical principles from this philosopher, but it's ultimately to be able to identify what are those different philosophical foundations that each of the different, even cultures in this global interactive set of projects that we undertake, both from a collaborative standpoint, whether it's an open source project or an open research or a research collaboration, we're going to be working with people from potentially all around, all the way in the other side of the world. So understanding and getting a little bit more insights on these philosophical foundations can only allow us to gain what could be deeper levels of empathy, where we would be able to come into much more powerful agreements. Because from what we have been able to see, a lot of this in the higher level, the direction is going to be towards what could be, minimizing undesired outcomes, minimizing what could be like, harm to humans. Now the core thing is to ensure that the way in which we agree, it is more as powerful as it can be created. Now, this is of course very high level and very abstract. Fortunately, there's a lot of resources that we can leverage in order for us to be able to use as practitioners. These are two very interesting resources: the ACM Code of Ethics and Professional Conduct, as well as the Linux Foundation's Principles for Trusted AI. These are actually a collaboration of principles that we were able to publish with the Linux Foundation, and it's quite an interesting project, given that it is principles for the governance and for the projects themselves. So this is very much relevant to perhaps individuals that are looking to adopt a set of like key areas of importance, these Northern Stars, to focus on different areas. Now, there may be the question of, well, as a practitioner or as an organization, as a team, principles or ethics guidelines may sound as something that would be either potentially relevant or would be red tape that would just slow down by putting useless process. But if you actually take in the case of the ethics guidelines and professional conduct from the ACM, and you read them, things like strive to achieve high quality, maintain high standards, know and respect existing rules, you can't read this with a straight face and say that actually following this isn't going to end up just allowing you to create much more robust and much more meaningful work, right? Ultimately, this is not just good for business, but it's good for the AI systems that are being designed and deployed. So this is something that we as practitioners can not just adopt, but contribute through the open work streams that are happening, similar to the one that I mentioned with the Linux Foundation that has the Trusted AI working group which anyone can join. And I'm going to actually reference some of those things. Now, that is on the higher level principles, going one level deeper into what would be the industry standards, right? And industry standards are an interesting set of resources, starting for the fact that they are actually developed by practitioners like yourselves, for practitioners like yourselves. So this is the the ability to define what would be repeatable, harmonized, and agreed and documented set of processes to do things as best practice, right? Things that are examples of industry standards that are ongoing could be the IEEE's standards for transparency and algorithmic bias. This could be even standards like the C++ language standards, right? These are all very similar to what you may find intuitive as open source. These are also open working groups with practitioners that are all trying to collaborate to try to identify what could be these best practices, what could be the frameworks, what could be the processes and the way to evaluate the standards themselves. And you can actually get involved with some of these ongoing ones that I mentioned with organizations like the ISO, the IEEE, even the Python Software Foundation. What you have to do is basically just join some of the newsletters or the groups, the email groups, listen to the ongoing discussions, and then be able to contribute to the discourse, to the discussions in the way that you are able to. So this is actually quite an exciting way to be able to contribute to some of the ongoing work streams. Now, the final part of this high level of this middle component, so we've covered the principles, now the standards and regulation, is this part about regulatory frameworks. And as practitioners, we often see regulation. We may have here that regulation is playing catch up, right? What we are seeing now is that actually it is tech companies playing catch up with some of the innovation that has been coming up with, for example, in the European Commission, things like the GDPR, right? The data protection regulation, which has actually done strives to ensure the protection of individuals' data. And then similarly, now there was another initiative that they are now working towards publishing the AI regulation framework, which they actually opened a consultation, which we provided some comments for on that AI regulatory proposal. Again, as practitioners, this is something that you can contribute to. A lot of governments and also public organizations, they open up consultations where they say, hey, we're looking to gather comments and thoughts about this specific thing that we're looking to publish or work further on. Would you be able to provide some comments? And within the ACM, we actually have the Technology Policy Council, which is an open group that allows for practitioners like yourselves to be able to get involved, contribute in the different work streams, and contribute to some of the open consultations. So if you would be interested to have your say on these areas, then there would be a lot of different very exciting components. Now, of course, when it comes to regulation, we can all agree that bad regulation is bad, but good regulation can actually be a catalyst for innovation. And the reason why is because it would be ensuring that best practices are followed and bad actors are mitigated, right? And this is important when we want longevity in the case of innovation, right? It's not just about like getting everything out and just putting everything in society and then just trying to get all of this innovation there, but it's about making sure that it's sustainable and that it has a long-term capability to have positive impact in the societies where all of this is being used. So this is quite important. Now, the final thing that I want to mention about regulation is that there is a very interesting repository with different resources that you can get involved with if you're interested. But I also don't want to get some people to fall asleep. Now that we've covered the two main components, we go to the deeper part, which is the open source as foundation. And this is key, as now open source is now the backbone for critical infrastructure in society. So frameworks could be like TensorFlow, like PyTorch, or even deeper like the Linux operating system. Those are actually at the core of a lot of the production systems that now our society is starting to pretty much run on. And the reason why this is important is that because these high-level principles, the things that are being strived towards as these, northern stars that are being followed as the, ideals, have to be built by design through this underlying infrastructure that is being continuously developed. And similarly, the principles themselves are going to be useless unless we actually have those foundations in place. And that means that the open source leaders or contributors like yourselves, even if it is just on the discourse, are important to involve in this different interaction between the different levels. So this is absolutely critical, and is more as a call to action for people to get involved and contribute through these different work streams, which are already very exciting. Now, there is also a lot of acknowledgement from organizations that are taking this open source very seriously, adopting this open source as part of their AI strategy. So you see organizations like Facebook with PyTorch, Google with TensorFlow, Tencent with the different frameworks. A lot of organizations are actually taking this very seriously, which emphasizes the importance. And if you're interested to actually have a look at what the ecosystem of machine learning production tools looks like, we actually reference a Git list where you can pretty much encounter most, if not a large amount of the available tools across a very different range of components. If you want to contribute, if you want to just learn more, this is a great resource to get involved with. Now, if you want to actually contribute to some of the higher level work streams, as I mentioned, these software foundations like the Linux Foundation, the Apache Foundation, the Software Conservancy Foundation, they all have active working groups where you can actually get involved. It doesn't have to be specifically just contributing to code. It can be, as I mentioned, things like, the high-level trusted AI principles, or for example, at the Linux Foundation, I chair the GPU Acceleration Compute Committee, where we explore about cross-vendor GPU acceleration, best practices, projects, etc. So there's a lot of different exciting parts where you can get involved, and I encourage people to get involved with. So now we've covered this concept of programmatic governance. We talked a little bit about principles, standards, and open source. Now let's actually take the deeper step into the production world and see what that actually looks like when it comes to those best practices. So before that, we need to understand what is the challenges when it comes to taking this to production. Right? And the challenge is that, unlike just software systems, production machine learning systems are hard. Right? There's a lot of specialized hardware at play. There are complex dependency graphs for the data flow. There are compliance requirements when it comes to the use cases that are being worked around for this machine learning systems, as well as the complexities of reproducibility. And again, linking a resource that you can delve into what are some of the deeper trends of the challenges. But now is the question of how do we address this? And one of the key things and trends that we have identified of best practices that this has been able to address is through a combination of multiple things. The first one is from a technology perspective, is identifying what goes beyond just the tools, the specific tools that are being used. And this is what we refer to as architectural blueprints. What are the key requirements as the core principles and technology necessities that are needed at every single potential stage of the machine learning lifecycle, whether it's the training data ingestion, feature engineering, model selection, the persistence of the model, the deployment of the model, etc., etc. What are the core requirements to then be able to understand what are the technologies that should go or shouldn't go in each of them? Similarly, to understand what are the different individuals that should be involved at each of these, programmatic stages. And this goes into a bit more detail of what is the interaction that you should take into consideration when it comes to those cross-functional structures that go beyond just the technical and research side, right? So how you ensure that the different teams from the products, the designs, even the compliance side interact with the different technical stakeholders. This is actually quite an important thing to understand, particularly also depending on the nature of the project that is being carried out. And similarly, when it comes to the different cadence of the teams, whether you have like your blue sky thinking research or your strategic research, being aligned into what would be more of those product teams, productizing different features together closer with what could be more of that prototyping, that sort of shorter term type of roadmaps, as well as the environments that would be more sandboxed to carry out experiments in a less risky manner, right? And ensure that things are validated in an iterative sense throughout the core planned intersections across each of these teams. So ensuring that cross-functional interaction is done from a technical architecture level, from a team interactions perspective, and from a strategic long-term planning perspective, and how each of these different teams and individuals would interact. Now that we've covered a high-level intuition of what could be single 1 hour sessions plus for each of the slides around the programmatic governance side, around some of the more practical, ways of tackling this production machine learning challenges. Let's put everything together into what would be a practical use case. So let's see what this would look like if we were to take a data science project and try to see what are those principles that can be strived to, as well as what it would mean to not follow those things. So if you want, again, another 1 hour session that actually delves into this all the way to the code, to the deployment, and to the scaling, you can actually try it out yourself also with the Jupyter notebooks. But for now, we'll just take a high-level intuitive tour around this. We're going to be taking a set of core high-level principles as the main sort of important ones, based on the context in which we're dealing with. This is going to be the bias evaluation, explainability, and human in the loop. We're going to now actually take a use case. Let's assume that we have an existing process that consists within our business of a set of domain experts that receive a loan approval application, right? And they basically see that the loan has some attributes, they have to approve it or reject it, and this happens manually by these individuals. But now we actually see that business wants this to be automated with machine learning, some state-of-the-art algorithm that they actually found online, and they want to actually use that in production. So the data science team, what they would do, as they would always do, they would actually have a look at following the usual data science process, which right now it's massively abstracted into what could be gathering the training data, transforming that into features, training the model, persisting the model, and then deploying it so that unseen data goes through that. So in this case, it would be unseen applications that would be automatically predicted whether the loan application would be approved or rejected, right? So what the data science team received is basically a set of 8,000 rows of existing training data consisting of the applications, basically the attributes, and then whether the loan was approved or rejected. So they basically trained a model, and lo and behold, they were able to see that they got 99% accuracy on that model that they trained. So they were very, very happy. They said, okay, we have a great accuracy, so let's deploy that model. And guess what? That was a complete disaster. And the reason why is because they realized that the model, all it was doing is it was basically just rejecting every loan. Even though someone actually was supposed to get that loan approved, it got rejected. When they actually said, well, why did that happen? They actually looked at the data from production and from training, and they saw that the actual number of examples that they had for the training data were pretty much all rejected loans, which means that the model just basically realized that if it just rejected all the loans and the internal sort of weights were just basically weighted towards rejecting all the loans, that would be a 99% accuracy. Whereas in production, the data was expected to be otherwise. Now, they were thinking, well, maybe I can just put all of the number of examples aligned, but then they realized that actually within the subclasses there was still some imbalances, which if they would just have trained it as is, then they would have just still gotten something else wrong. And ultimately, what they realized is that for this specific use case, it was also not just going to be to ensure that every single subclass intersection is completely uniform, because what does that even mean, right? Ultimately, what they needed is to understand what is the context and the impact where the use case was being used, what is the current sort of humans that are involved within this process, and what is the requirements to ensure a representative alignment to what is being seen and needed for this specific use case, as well as some other potential challenges that could involve even on the human perspective. This would then involve different tools and processes for that perspective, just allowing and ensuring that domain experts within whether the technical or non-technical areas are included when it comes to the data analysis, when it comes to the model evaluation, when it comes to the model deployment and the model operation. So there could be other tools that they could use, like up sampling, down sampling of data, taking into account correlations, using different statistical methods to evaluate the performance of the models, or even using some AI explanation techniques. Irrespective of that, there is no single silver bullet that they could just use to actually just solve all of these things, but it's to take a step back and identify the best practices and the most relevant best practices for that particular use case. And of course, most importantly, is that not all can be solved by AI. And perhaps it could be just that a percentage of the use case, 30% would be the prediction, but then there would still be some human in the loop that would be involved. Particularly given that when you're running around with a hammer, everything can look like a nail. And from, our use case, to ensure that we are ensure the best practice, we have to consider everything, not just the algorithms. So with that said, I think we've covered a very vast range of different topics, each of them that can lead into deeper dives of potentially, much more time. But with that, today we covered those motivations for responsible AI, the responsibility hierarchies, the programmatic governance, the production considerations, and a practical example, all which hopefully will have given you an intuition and a set of potential actions for you to get deeper into the area that you find most relevant. And with that, thank you everybody for joining my talk today on Meditations on First Deployment, a practical guide to responsible AI. I hope you all enjoy the rest of the conference. Thank you very much.
Hi, everyone. Thank you for attending this session. And thank you, Alejandro, for your great talk. In this section, I'm going to ask you the question from the Rocket chat. So feel free to post any question that you might have. And in the meantime, I'm going to add some questions until some other question from attendees comes up. Okay, so Alejandro, can you give us an example of a good regulation as a catalyst for innovation? And following up that, does easing regulation may have a similar effect on the catalyst effect for the innovation?
Yeah, that's a great question, Adi. Thank you very much. So I mentioned briefly some pretty successful cases where regulation has been able to drive forward desirable outcomes. An example of that would be GDPR, which led into much more sophisticated capabilities and more up-to-date capabilities for protection of personal information. And right now we are seeing an expansion of that, even in the European Commission, where they have just published the AI regulation proposal, which is aiming to provide a regulatory framework around that. Now, the interesting thing is whether regulation, to your second question, can be a hindrance or a catalyst to innovation, especially for things like research, as well as applied use of machine learning. And the important thing to take into consideration is that objectively, as I mentioned in the session, bad regulation, we can all agree, is bad and is going to have an adverse effect. But ultimately, good regulation can have a positive impact. And the positive impact would be seen ensuring that we can restrict malicious players and enforce best practices in the use of some emerging technologies that are coming out and being applied in areas that may not have been used before, that can have effects in society, that can actually affect individuals for even generations. So it is important to make sure that not only we just have regulation, because also bad regulation can be bad, but also that we make sure that it's done in the best way possible. And that is, as I mentioned, one exciting part that practitioners, ourselves, yourselves, can get involved in contributing into the regulation that is being put together, like the resource that I shared in the presentation, and that I'm happy to give a little bit more detail. But yeah, that would be a brief, high-level overview on that.
Okay, thank you very much. So there is a question from the Rocket chat from Angelica Cadillo, if I spell it correctly. She says, hi Alejandro, what are your thoughts on leveraging open source software to develop ML system and preserving intellectual property? Great, thanks.
Yeah, thank you. Yeah, that's a really interesting question. So I think open source is absolutely critical for ensuring the responsible development of systems, especially in fields and tools that are serving as the backbone infrastructure for entire fields. Like, for example, in the case of some open source projects like the Linux operating system or the Kubernetes framework in the broader computation space, as well as in the more machine learning specific space. A lot of the tools that we love and use in our day-to-day lives, whether it is JAX or TensorFlow or PyTorch or scikit-learn. These are frameworks that are critical not just to have in place, but for them to be open source, for practitioners to be able to expand in the same perspective as research is, to ensure that individuals, whoever can actually contribute and further those fields. I mean, could you imagine if TensorFlow, PyTorch, scikit-learn were all closed source, how much that would hinder research and how much that would hinder innovation in this space? And into your second point about preserving intellectual property, ultimately, right now in the commercial space, there are a broad range of organizations, including tech giants and traditional businesses, that are now seeing open source as a primary strategy for ensuring that they can develop intellectual property and using that in a strategic way. And we can see that with a lot of tech giants like Facebook or Google or even Tencent, Alibaba. They have very, very aggressive open source strategies that are really taking that IP perspective and also just furthering the field as a way to contribute into their own internal capabilities. So yeah, I think open source is absolutely critical, as I mentioned, and I would send a call to action for practitioners to get involved because it's absolutely important.
Thank you very much. So I have a question on my own, how to make sure our involvement in the regulation and open source process results in ethical consequences?
Yeah, so I think that goes back to the first question. I think ultimately a lot of the focus of the presentation that I provided was aiming to tackle it from both a top-bottom and bottom-up perspective. Top-bottom being through the principles that provide those North Stars, and bottom-up by identifying not just what does it mean to build a good system, but taking it in the other way, identifying what can we all agree is a red flag or a bad practice, to ensure that we can identify the core touch points, processes, and requirements that we as practitioners can introduce to ensure we can minimize and mitigate undesired outcomes. And through that, we are never going to be able to, like in cybersecurity, make systems that are unhackable or that can never be used for something bad or that can never have undesired outcomes, but is to make sure that we can introduce the best practices possible to optimize for what would be the larger population and society. And that's where regulation, but also standards and self-regulating industry interactions would come in to make sure that those are actually carried forward. So I think it is absolutely critical, of course, on the regulation perspective, but I also made it clear that as practitioners, we do have a growing responsibility, whilst at the same time, large ethical challenges cannot just fall on the shoulders of a single data scientist. It has to ensure that it's at multiple levels of that responsibility hierarchy. So I would say, it is absolutely critical to ensure good outcomes, but it is important to not just rely on something like regulation as a silver bullet.
Okay, thank you very much. So can you talk more about the impact of open source, please?
Yeah, so well, I mean, I think as I mentioned on quite a lot about open source, and I'm very positive on the impact that it can have towards ensuring the responsible development of AI systems and just general systems. I would say that now what I would emphasize is that as practitioners, as contributors to open source, whether it's just using it, contributing documentation, or actually contributing to the development of the code, we have a very important role to play in society, given that a lot of the discourse that is happening at multiple levels, developing of standards, developing of regulation, developing of best practices, the voice of these open source practitioners and just general practitioners is absolutely key. And this is one of the reasons why I was emphasizing that everyone that is attending this conference would have the opportunity to make a positive impact towards the frameworks, whether it is technical or higher level, that are being developed towards ensuring the responsible operation, development, and design of these systems. So what I would say is that as practitioners, it would be great for you guys to get involved in the open source projects, but not just when it comes to code, but also the open initiatives like the development of standards, as well as the consultations, as I mentioned, of regulatory proposals. Mm-hmm.
Okay. Actually, I was wondering if I can ask a question. I don't know.
Yeah, go ahead. Yeah, please go ahead. Yeah.
I'm curious about your position or your views on regulation in terms of how it could benefit, would say, larger companies over smaller companies who are better positioned to say adapt, for instance, to GDPR, right? Like these large companies that have a lot of staff are definitely better positioned to adapt to these regulations, and whether this affects new players that are coming into the field.
Yeah, no, that's a great question. I mean, and being quite blunt, organizations, large corporates actually spend a significant amount of resources on what people often refer to as lobbying, right? Being involved in the different discourses that are developing the regulation. And of course, they're going to have a specific agenda. The benefit of making sure that those discourses are open, ensure that actually the different agendas converge into something that would be beneficial ultimately towards all of those perspectives. And this is also where I am emphasizing the importance of practitioners like ourselves to make sure that we have a voice through organizations like the Association for Computer Machinery, the Linux Foundation, where we can actually push for a change towards things that are going to be potentially important for not just other practitioners, but also broader society, or providing a perspective that may not be currently in place within the current organizations represented. Right? This could be different backgrounds, different experiences, different geographic upbringings, whatever it is. It is important to ensure that there's a broader voice when it comes to those places. And I absolutely agree that if we don't have that, there may be a potential challenge of it diverging and becoming biased towards purely soulless capitalistic directions, which is not the best for the longevity of society. But yeah, that's a good question. Mm-hmm.
Thank you very much, Alejandro. Thank you for the answer.
Thank you, Alejandro, and thank you, Andres, for your great question. I think that's about all the questions we have. Thank you, everyone.
Thank you all. Thank you for joining.